Hi, welcome to Sachin Study Tech. Today topic is theta notation. When you can use a theta notation, when the big O notation and omega notation asymptotically equal, then you can represent theta notation. So asymptotic equality, that is the same rate, it represents the upper bound and the lower bound of the running time of an algorithm. It is used for analyzing the average case complexity of an algorithm. So the definition, let G and F be the functions from the set of natural numbers to itself. The function F is said to be theta of G if there are constants C1, C2 greater than 0 and a natural numbers n naught such that C1 into G of n less than or equal to Fn less than or equal to C2 into G of n for all n greater than or equal to n naught. Now we can see this is the f of n function, f of n equal to 3n plus 2. Here it is, if you can satisfy this equation, C1 into G of n less than or equal to f of n less than or equal to C2 into G of n. Now we can see this part, C1 into G of n less than or equal to f of n, that means it is a omega notation. You know, best case time complexity, C1 into G of n is the lower bound and f of n is the upper bound. Now we can see here f of n less than or equal to C2 into G of n, it represent upper bound, here it is upper bound, here it is lower bound. So f of n is the average bound, Now C1 into G of n less than or equal to f of n, already you know that here it is a omega notation. Here the C1 is, in that case, for example, f of n is 3n plus 2 less than or equal to C2 into G of n value is n. Here also C1 into G of n is the n less than or equal to 3n plus 2. You know already the C1 value is 1 and C2 value is 4. In previous case you are consider in omega notation the C1 value is 1 and in big O notation the C2 value is 4, the C value is 4. Now here the n value is 1, now n value is 1. So C1 is 1, 1 into 1, 1 less than or equal to, here n value is 1, 3 into 1 plus 2 that is 5 less than or equal to, C2 value is 4, 4 into 1, 4. Here it is 1 less than or equal to 5 is satisfied, but here 5 less than or equal to 4 is not satisfied for all n equal to 1. Now we can see n value is 2. Now C into, that is 1 into 2, 2 less than or equal to 3 into 2, that is 6 plus 2, 8, 8 less than or equal to, and C2 value is 4, 4 into 2 that is 8. So it is satisfied. 2 less than or equal to 8 and 8 less than or equal to 8, it is satisfied. Now we can check one more value here, the n equal to 2, n equal to 3 and 3 into 1 3, 3 less than or equal to 3 into 3 9 plus 2 that is 11 less than or equal to, so C2 4 into 3 that is 12. So here also satisfied. Now we can say that f of n equal to theta of G of n. Why? Here it can satisfy for all n greater than or equal to, here the value is 2. Now you can see here the n naught value is 2. You can take 2 or more than 2. It is satisfied that equation. Then you can say that f of n equal to theta of g of n for all n greater than or equal to 2. Now you can see c into g of n. C into g of n is a lower bound. It is a lower bound. Here it is average bound. Here it is c2 into g of n. It is a upper bound. So this is the theta notation. When you can use the theta notation? Whenever the big O notation and omega notations are asymptotically equal, then you can use this theta notation. You can represent the time complexity. Thank you for watching.